All right, greetings every one of you. So happy to have you once again in this episode 5 of this series. We have been looking at arithmetic of finance. All right, so you will recall that in episode 4, we solved problem on depreciation and rate of growth. And of course, in this episode, we want to consolidate that knowledge by adding further problems, okay, that will also help to expose you to more difficult questions or more questions that require some analytical thinking that will engage your brain. All right, so let me walk you down to the class and let's see what we have for today's class. I'm going to be a bit faster today because in one of the questions I have a lot of explanations to make at that question. All right, so you can see this is a continuation of where we stopped. That's why starting from example 6. Okay, so the present population of a village is 48,000. If the birth rate is 13.8% per annum and the death rate is 6.3% per annum, calculate the population of the village after 2 years. Now, my question to you is, how would you solve this problem? That's my question to you. I'm sure that many of us would have done the compound birth rate, kept it separate, done the compound birth rate, kept it separate, and now do a subtraction to get the net population of the city. Well, that I wish that could have been, that was correct, but it's definitely wrong. All right. The reason is that both this the death rate and the birth rate is taking place at the same time. Okay, they are not taking place differently. Assuming they were taking place at different times, then of course it could have been correct. Okay, it could have been correct, because now if you, let's just say, because by this you're thinking, or what you think is to be correct, that you do the birth rate, keep it separate, do the death rate, keep it separate, and do subtraction. If that to be correct, it means that I can do my death rate first and keep it, then do my birth rate second, and before I do my subtraction. Now let's say you want to do your death rate first, now at a percentage, and you now do a compound death rate, and everybody dies in that community or in that village. So what number of people are you going to use to now do your birth rate? Okay, so you discover that logical reasoning is problematic. It's not correct. It's not accurate. So this is like a tug of war. All right. So when in a normal tug of war, when two people are dragging themselves, or a group of people are dragging a rope in opposite direction, you see, a particular people is going to move in a direction of a higher strength. All right. So it's like a tug of war. So we need to find the net rate and not the net population by doing them separately. So since they are taking place simultaneously, which way is the rate going to go? Is the rate going to go in the direction of the birth rate, or is the population going to decrease in the direction of the death rate? So it is the rate rate you need to find. So that is how it's done. So now say birth rate. All right, our birth rate is equals to 13.8%. That's our birth rate. Then our death rate. The death rate is equals to 6.3%. All right, so the net rate, okay, which I will now call R, is equals to 13.8 minus 6.3. So our net rate now is equals to 7.5%. Now, which formula do we use? Okay, do we use a positive compounding amount, that is inflation, or do we use a negative compounding amount, that is depreciation? Now, that can be a problem. Now, I'm going to use a positive compounding amount, all right, which is inflation, 1 plus, that's what I mean by positive, 1 plus R over 100 raised to power n. And why I'm using this formula, why I'm using plus here, this one, is because the net rate is positive, okay? The birth rate is higher than the death rate. So it means that the net effect of this rate is going to be an increase in population size. But assuming the death rate was higher, of course, I could have used A equals to P into 1 minus R over 100 raised to power n. So please, what we use at any particular time depends on the interpretation, the proper interpretation of the question we are solving. So that implies that when we substitute A is equals to 48,000 into 1 plus 7.5 divided by 100, and of course raised to the power of how many years, n is equals to 2. When we use our calculating device to solve this problem, we end up having that after 2 years, that the population would have increased. Their population is going to be 55,470 people. So that will be their population after 2 years. And of course, you can find the increase in population by doing subtraction. Alright, so let's look at the next question now very quickly. In question 7, we are told that in a certain year, the population of a street was 6,000. During the next year, that means after 1 year, it increases by 10% due to increased cases of premarital sex. Alright, then it decreased by 5% in the following year. What is its population now? Alright, so for this question, this is the right thinking now, which is what you thought for the other question, is that calculate the increase first of 10%, get it. Then now calculate the decrease. And now get it. That will not be your final answer, but you're not doing any subtraction. That is just the only thing. You're not doing any subtraction. Now let's look at it this way. I invested let's say $1,000 in a bank. Alright, the bank was doing well. Alright, 10% of 1,000 is 100. Okay. Alright, so that is going to give me, so I made $100 after 1 year. So my total money in the bank now, my total amount in the bank is $1,100. That's good. Now in the next year, which is the second year, after the 1 year now, say the following year, the bank, there was a crash in the financial market, so the bank made a loss of 5%. Okay, there was a reduction of 5%. So the reduction of 5% is 5% of original amount, is 5% of what I have in my account, because my money is still with them. Because in the next year, it then decrease. So it's now what I now have in my account that is decreasing. So have the proper understanding of a question before you solve. So it now will decrease based on the $1,100 in the account, not based on the 1,000 I put originally. No, because the 1,000 I put originally has increased to 1,100 before it's not dropping. It then second statement, after something has happened, it's then. Alright, so that is the proper interpretation. So this one is not a net rate because they're not taking place at the same time. One rate will happen and produce an effect, then another rate will now come and use the effect of the result of the first rate and now produce another result. Alright, so that's what we do here. So when I say our first year, so we calculate it year by year. Okay, first year. So remember what I said before, that when you have some question that does not comply to a particular formula, of course, you don't use the one formula to get all of them. You have to solve them year by year or period by period to understand what is happening. Okay, so our P for the first year is 6,000. Of course, and our rate is equal to 10%. Then what do we have again? We are asked that the population increased, so it's increasing. So A is equal to P into 1 plus R over 100 raised to the power n. So, and our n is 1. Alright, so when n is 1, of course, even simple interest formula can work. So have our A equals to 6,000 into 1 plus 10 over 100 raised to the power 1, because it's just for 1 year. Alright, when we use our calculating device to process this, we are going to have our amount after 1 year is equals to 6,600 people. Alright, so the second year now, alright, there was probably a problem in that particular community. Okay, so it now decreased. So our P now, remember the second year now is now working based on the outcome of the first year. The outcome of the first year is this. So the P for the second year is going to be 6,600. Alright, then the n is also equals to 1, because just after 1 year, the next year equals to 1. Then the rate is equals to 5%. Alright, now though the rate is changing, but they are changing in opposite direction. So don't go and use compounding formula that uses change of rate. Okay, no, the rate is actually changing, but this question does not conform to equation 1 of the compound interest, nor the equation 2 of the compound interest, because now it is changing a rate, but in opposite direction, not in the same direction. That is why, once again, we are analyzing year by year. So for this one, since it depreciated, so we use A equals to P into 1 minus, no longer plus, R over 100 raised to the power n. Okay, our amount is equals to 6,600 into 1 minus 5 over 100 raised to the power n. And we will process this with our calculator. So the present amount now, okay, if it's in money, will now be 6,270. Okay, but because it's population we are dealing with, the money makes it easier for some people to understand. So we're talking about 6,270 people. Is that well understood? Alright, perfect. Okay, let's look at the next example. Here, we are told that the cost of a laptop depreciates by this. So this is our amount during the second year. Now, I want to point attention to this statement, during the second year. During the second year. It didn't say at the end of the second year. During the second year means I bought this calculator this year. That is the first year I bought it. During the second year is next year. Okay? But if you are saying at the end of the second year, that means n is equals to 2. Okay, please take note of that. And by this amount during the third year. So during the third year is n equals to 2. While at the end of the third year is n equals to 3. So take note of this little grammar or English. Okay, calculate the rate of depreciation. Alright, so let me explain this question to us before we solve it very well. Now, in this type of question, remember, just tell you to use simple math to solve complex math. That's what I normally tell my students. Use simple math to solve complex math. Now, let's throw our mind back to compound interest. Compound interest is a situation whereby our interest generates interest. For instance, you put $100,000, your P is $100,000, okay? That is your original amount, and it is 10% compounding. So when you make 10%, of course, 10% of 100,000 is 10,000 naira. That is what you make after 1 year. That's your interest. So your interest is going to become 10,000. Now this 10,000 is not returned to you. You now invest this 10,000, okay, in the next year. You invest this 10,000 the next year by saying your next profit. This is interest 1. Your next year interest is going to give us using PTR, okay, over 100. You're going to have, you now invest this money now 10,000, okay, multiplied by 1 because it is for the next year, so T is 1, and the rate is also 10, then over 100. Alright, over 100, and of course your second interest is going to give you 1,000. This is your second interest, 1,000. Alright, then if you now invest your original principal again, which is 10,000, 100,000 rather, 10% of 100,000 is 10,000, then produce 1,000, that is 11,000. So that is how compound interest is. That's what we normally do. But to get that one, so now say 10,000 plus 100,000, that is 110,000, and 10% of 110,000 will give us 11,000 direct. Instead of calculating the interest of interest, which is 1,000, and now calculating the interest of the principal, which is 10,000, and making 11,000. So, but the point I'm trying to drive here is that at this next year, my interest is being invested at the same rate, okay, to produce 1,000. So the interest is reinvested in compound interest. So it can also be used in the same way. The depreciation is reinvested in compound depreciation, okay. The depreciation is reinvested. The depreciation of the first year and it is the same rate, okay. So the rate at which the overall is depreciating is the same rate at which the depreciation of depreciation will also decrease. Just the same way that the rate at which this interest is producing an interest is the same rate at which the original capital will also produce interest of 10,000 plus this 1,000 to give 11,000 for the second year. Alright, so that is the idea behind that. So that means if I had if I want to now know the difference, of course, I can do my subtraction. 11,000 minus 10,000 will still give me this 1,000. All right, that is the difference. Now we have gotten this explanation. Of course, let's now go and solve our problem. Now adapt this explanation to depreciation. Okay, so we now have our depreciation for the first year, depreciation at year 2. Okay, not at the end of year 2. Okay, at year 2 is, we are told it is 5,280. Okay, naira. Our depreciation at year 3 is given to us as 5,913.60. Alright, so what this question implies that when they compounded for 2 years, and during the third year, because during the third, that is for 2 years, when they compounded for 2 years, they got a depreciation of this. This was the depreciation they got. When they compounded for just 1 year, okay, under depreciation, they got this. So that means they did not give us the information about the principal and the rate. Alright, they didn't give us the information about the principal or the rate. If you want to use the formula to solve, it will lead you to quadratic equation, of course. You can solve, you have 2 formulas and you now start testing the one that will satisfy the equation. Well, that's okay for you, but I just want to show a simpler and faster way to also solve the problem. Because when you have quadratic equation, of course, one of the answers is going to be valid, okay, when you check. When you, after getting 2 answers, you now have to check which answer is correct. So one of the answers will be correct and one will not be correct. So that the correct one is what we are going to get here. Alright, so back to our normal thing. So we now find the difference in depreciation. Alright, so we now say change in depreciation. Okay, that's the symbol for change. Okay, between the second year and between year 3 and year 2 will now give us 5,913.60 minus 5,280. So our change in depreciation is actually 633.60. So this is our change in depreciation. Alright? Okay. So what does this thing mean? It means that when they invested this depreciation, if it was an interest, they invested this interest, okay, in the second year, okay, while at the third year, it now produced a profit of this. That if I'm changing this now to interest to explain to you. So if it was interest, that means they invested this, because change in depreciation is this one minus this. They invested this in the second year and now got this. So of which when you add this to this, you now have the interest they got at the third year, but we're talking about depreciation. Alright, so it means that this depreciation was what went in, okay, the depreciation of depreciation. That's why we have interest of interest. That means our interest can also hit another interest. That means this depreciation can hit further depreciation of this amount. Alright, so if we now use the interest formula, which is D, instead of same interest, now we are using depreciation formula, which is PTR over 100. What does it mean? It means that they invested this amount, okay, which is our principal. So it's not as our principal, alright, and this is the depreciation that they got, not the interest now. So the depreciation is this 6. They invested this amount as the principal, then they now arrive this at the interest. But we're talking about depreciation now. So they invested this at the principal, they arrived at this at the depreciation between the second and the third year. So this is our depreciation now. 633.6 is equal to the principal will now be this, okay, which is now 5,280 multiplied by the time between the second year and the third year is 1, and the rate is what we are looking for, because both the rate for the interest of and the rate for the principal is the same. Alright, just as I'm explaining with interest, okay, so it's also the same for. So if we find the rate now, with the depreciation and produce further depreciation, then that's what we can now use to calculate for the original amount. Alright, so we now have this. If we cross multiply, we are going to have 5280R is equals to 63300. Alright, our R is equal to 63360 divided by 5280. Alright, so when we divide the calculating device, our R is equals to 12%. Okay, so this is one of the answers you could have gotten if you have used quadratic, if you have used simultaneous equation, which would now lead you to quadratic equation. Okay, that is so. This is one of the. This could have been the correct answer you could have gotten. Of course, the other one should have been maybe probably. I've not tried that. Maybe around 88%. That should have been the wrong answer. Okay, because only one answer is going to be valid. All right. So now we have 12% for R. So we are not asked to calculate the original cost of the laptop. All right. The original cost of the laptop is the next thing we want to calculate now. Alright, so remember that they say during the second year, not at the end of the second year, so our time lag is 1 year. Alright, so it means that question B, that the time lag is 1 year. So can I say our using our I, if we are using depreciation, is equals to PTR all over 100. Okay, so we are now looking for this our depreciation. Now look up here. They say the cost of a laptop depreciated by this during the second year. That means the next year they bought it. Alright, not at the end of the second year. So our principal now is what we want to look for. That's what they're asking of the original cost of the laptop. That's what they're looking for. Now this is the depreciation because it says depreciated by this amount. Okay, if they are saying it's appreciated by this amount, this could have been the interest. So this is the depreciation. Now we are going to put here. We have already gotten the rate already. So and the time is 1 year. So depreciation is 5280 is equals to the principal is now what we are looking for multiplied by a period of 1 year. Okay, during the second year. Please remember it said during the second year, not say at the end of the second year. They multiplied by the rate. We are getting it as 12 over 100. Okay, so when we cross multiply, we are going to have 12p is equals to 528000. So our p is equals to 528000 divided by 12. Therefore, our p is equals to if you use a calculating device, they're going to have it as 44,000 naira. Alright, so that is our original amount of money invested. So this original amount of money is what was invested. Now, what is question 3? Okay, question 3 says the cost at the end of the third year. You cannot see the English here, at the end of the third year to the nearest naira at the end of the third year. So the cost at the end of the third year. Remember that it is depreciating. Alright, our laptop is depreciating. So our N, of course, our formula for A is not going to change. Okay, but our N is going to be 3. So for question C, when I say amount is equals to P into 1 minus R over 100 raised to power N. So the amount at the end of the depreciation is what I'm looking for. We're looking for this amount now. So we have our P, the original amount, which is 4,000 into 1 minus the rate at the found 12 over 100 raised to power 3. So this is where we use N equals to 3. Alright, and of course when we simplify this problem, we now have our amount at the end of the third year to be approximately, okay, approximately 34,074 naira. So that is the approximate amount to the nearest naira after 3 years. Okay, so please take note of those English I mentioned there. During the second year is just 1 year. This is the first year I bought the laptop. So during the second year is next year. The difference of 1 year. But when you say at the end of the second year, I mean this year have ended, next year have ended. That means 2 years has passed. Alright, so please take note of the use of such English because that can lead students to failure. Alright, so we want to stop here for this episode. Alright, but before we call it a day, quickly look at your classwork, and of course, once again, I just want to remind you that you should subscribe to this video, of course, to this channel, if you have actually learned something from this video. If you have been blessed from the series you have been considering, if your mathematical ability has been improving, and this video is of tremendous help to you, why not you subscribe to the channel so they can get notifications when new videos are being uploaded. And of course, we also need you to send in your feedbacks in the comment section for us to also see what you think about our channel, and of course make necessary improvements where possible. Do well also to recommend this video and channel to people that are looking for resource material to enhance their understanding in mathematics. This will be a great asset to them, and they will never forget you for that. Alright, here is your practice question before we go. Okay, question 1, this is the question, and of course you can see the answer there, and we also have the question 2, and the answer is also here. So please solve and check whether your answer is correct. And here is question 3 and 4. Alright, so, and those are the answer. Alright, it is a goodbye from me. We meet in the next episode, and of course I'm going to be considering hire purchase and instrumental buying in the next episode. See you at the next episode. It is a goodbye from me. Thank you for staying patiently. We'll meet in the next episode.